Alrighty. So, second kind of problem you're going to see is this kind. This is another way that you can measure something in the real world using similar triangles. We can do this. Okay. So we got Amy is 5 feet tall. She places a mirror on the ground and moves until she can see the top of a nearby tree. At this point, she is 2 feet from the mirror. The tree is 48 feet from the mirror. How tall is the tree? Okay, no idea what's going on here. Draw the picture. Each one of these problems, you want to draw a picture. If there's no picture, draw a picture. So, here is Amy. There she is. And she is 5 feet tall. Okay. And she's got, over here, she's got this little mirror on the ground. Here's my mirror. That's my mirror. Okay? Right? That says mirror, trust me. And she is looking into the mirror. And looking into the mirror at an image of a tree. Okay, here's the ground. Okay, so the tree is, let's pretend that worked. Okay, here's the tree. So she's looking at the mirror, and the image of the tree is showing up in the mirror. Now, when you see something in a mirror, the way light and reflection works is that this angle here is always congruent to this angle here. The angle of incidence, where the light is coming from, is equal to the angle of reflection. We're going to use this fact about light, how light works, for this sort of problem. Okay, if this is a right angle, if these two angles are congruent, and we know, so think about our triangle here. We've got a triangle. Well, this is a right angle, right? Because we're going straight up. And there's a right angle right here from the ground up to the top of the tree, that side. Okay, we've got two triangles. They have one pair of right angles and one pair of congruent angles and another pair of congruent angles, because the right angles are both 90 degrees. So we've got two similar triangles. We can use, again, just like we did in the last problem, use the ratios in the proportion statement to solve for one side of the triangles that we don't know. Okay, so what do we know? We know Amy is 5 feet tall. We know she is 2 feet from the mirror, so this distance right here is 2 feet. Okay, we know that the mirror is 48 feet from the tree, so this side is 48 feet. Okay, so we know 2 feet goes with 48 feet. Those are corresponding sides, so we'll set up our ratio. 2 over 48. And that's going to equal, we've got 5 feet over this side over here, the height of the tree. We'll call that h. 5 over h. Now notice I put, in both of these fractions, I have the height that goes with Amy, right, the Amy triangle on the top, and the triangle that goes with the tree on the bottom. I could have written it 48 over 2, but then I'd have to write h over 5 on this side. Anyway, I'm going to cross multiply, so I get 2 times h equals 48 times 5. So 2h equals 48 times 5 is 240. And then I divide both sides by 2. H equals 120 feet. So I know that this tree is 120 feet tall, just based on this little trick with the mirrors. How cool is that? You are going to do the same thing with all of your problems. They're either going to be this sort of problem with the mirror on the ground problem, right? And you're going to draw your diagram. It's going to look something like this. Or it's going to be one of these problems with the shadow problems, right? Looking for shadows. Okay, shadows, you're going to draw two triangles like this. In each case, we're using similar triangles and finding the missing side using the proportion. Okay?